viewers. Welcome to this presentation on distribution system HT phase drop. Distribution system is HV, mostly 11 kV, distribution feeders from distribution substations. Numbers of feeders run around to feed power in nearby areas. Feeders may be for rural, agricultural, urban, industry and mixed load or express for HT users. HV/LV 11,000 by 433 volts distribution transformers of appropriate capacity are installed at strategic locations for local LV supply consumers. There may be the incidences when one of the HV phases supply is not available to distribution transformer. It may be due to operation diffuse, opening of jumper, conductor snap or purposefully for load shading. In this condition, voltage on LV side is disturbed. Here is analyze about secondary LV voltages under different condition. Here is 11,000 by 433 volts delta star DY1 distribution transformer. There are 3 primary coils P1, P2 and P3 and 3 secondary coils S1, S2 and S3 assembled on 3 limbs A, B and C of transformer core. B is center limb whereas A and C are side limbs as in the figure. Primary coil P1 and secondary coil S1 are on one side limb A. Primary coil P2 and secondary coil S2 is on center limb B. Primary coil P3 and secondary coil S3 is on other side limb C. 3 primary coils are interconnected in delta as usual and is connected to 3-phase supply RYB. There are 2 possibilities depending upon which phase is out. Case 1. B phase is open. In this condition, primary P2 is across normal line voltage, whereas primaries P1 and P3 are in series across line voltage. The magnetic flux induced in the core is as shown in figure. The magnetic flux has 2 paths. Total flux of center limb is divided and flow through side limb on each side. The length of both the paths are equal. Therefore, permeability, magnetic conductivity, is also equal and consequently flux through both the paths are equal means half of total flux. As a result, induced voltage of secondary coil S2 on center limb has normal phase voltage. But secondary coils S1 and S3 on side limbs have induced voltage half of the phase voltage. Obviously, voltages in secondary S1 and secondary S3 are opposite to that of voltage in secondary S2 because of direction of flux is opposite. Vector diagram of secondary LV voltages. Rated LV line voltage is equal to 433 V. Rated LV phase voltage is equal to 433 3 is equal to 250 V. Phase voltages. VNB is equal to VPH is equal to 250 V. VNY is equal to half VPH is equal to 125 V. VNR is equal to half VPH is equal to 125 V. Line voltages. VBY is equal to VPH plus half VPH is equal to 250 plus 125 equals 375 V. In line voltage addition. VBR is equal to VPH plus half VPH is equal to 250 plus 125 equals 375 V. In line voltage addition. VYR is equal to 0, 0. Case 2. Y phase is open. In this condition, primary P1 is across normal line voltage, whereas primaries P2 and P3 are in series across line voltage. The magnetic flux induced in the core is as shown in figure. The magnetic flux has two paths. Total flux of side limb is divided and flow through center limb and side limb. The length of both the paths are unequal. Therefore, permeability is also unequal and consequently flux through both the paths are unequal. Part of the flux through center limb has short path, so has high permeability and consequently higher flux. Part of the flux through side limb has long path, so has low permeability and consequently lesser flux. So induced voltage of secondary coil S1 has normal phase voltage. But induced voltage on secondary coils S2 on center limb has more than half the phase voltage, whereas secondary coil S3 on other side limbs have less than half induced voltages. Voltage in secondary S2 and S3 are opposite to that of voltage in secondary S2 because of direction of flux is opposite. Vector diagram of secondary LV voltages. Rated secondary line voltage is equal to 433 V. Rated secondary phase voltage is equal to 433 is equal to 250 V. Let dV is 25 V. It depends on core. Phase voltages. VNR is equal to VPH is equal to 250 V. VNY is equal to half VPH plus dV is equal to 125 plus 25 equals 150 V in line voltage addition. VNB is equal to half VPH, dV is equal to 125 minus 25 equals 100 V in line voltage addition. Line voltages. VRY is equal to VPH plus half VPH plus dV is equal to 250 plus 125 plus 25 equals 400 V in line voltage addition. VRB is equal to VPH plus half VPH, dV is equal to 250 plus 125 minus 25 equals 350 V in line voltage addition. VYB is equal to dV is equal to 2 times 25 equals 50 V. Secondary voltages are not normal phase voltage. One phase has normal phase voltage, whereas other two phases have half or little more or less than half phase voltages. Partial secondary voltages in two phases are in line and opposite to normal phase voltage of third phase. There is no phase shift of 120 degree as normal. In this condition, this LV supply is not suitable to produce rotating magnetic field necessary to run induction motor. Therefore, this arrangement is suitable to suppress motive power load in distribution system while allowing essential domestic single-phase loads of light, fan, refrigerators, etc. So this method is adopted for load shading in distribution system to control load on power system when power system is facing shortage. All single-phase consumers are connected on phase having normal voltages. But loading on three phases is unbalanced during normal operation. Phase having all single-phase consumers connected get critically loaded during normal operation. Alternate arrangement is to have single-phase connections equitably distributed on all the three phases as usual. In this condition, 1/3 consumers get normal phase voltage and remaining 2/3 consumers get reduced voltage during load shading period. Lamps work with reduced light and fan at low speed. Tube light and fridge may not work. Sometimes switching off phases by daily rotation is adopted for equitable benefits to all consumers. However, mischievous users use voltage booster and/or capacitor to get normal voltage and phase shift on one phases to run three-phase motor. This supply have neither balanced voltages nor balanced phase shift. Yet it is capable to start and run three-phase motor. But it is detrimental for user as well power supply company due to probability of failure of motor and distribution transformer. It also upset the very aim of load shedding. Next video is about modified version of this for different pattern of LV voltages. Please like, subscribe and recommend others if found worthy. Viewers' comments welcome. Thank you viewers. Bye until meet again in next episode.